So once again, when we're looking at a power series, there's only three different things that can happen in terms of convergence. Either the series only converges for x equals a. It's the only value of x that this limit will give a sensible value. Or the series will converge for all values of x. No matter what x I put in this formula, I will get a limit that converges. Or there will be some positive number, here we're calling capital R, that controls how far away we can get from the number a and still get convergence. So we could go as far as positive R to the right. We could go as far as R to the left. Right? That would cover both cases for absolute value of x minus a is strictly less than r. And if we go any farther than that, if the distance from x to a is greater than r, then we will diverge. So far I'm just repeating what I said in the previous clip. Now, if we think about this as intervals, there's, again, three different possibilities. The interval is just a single point. The interval where this function converges is from the whole real number line, minus infinity to infinity. Or we have an interval that has a, the number a, right in the middle of it. So each of these we'd call the interval of convergence of the power series. Power series will have some interval where they define a function. And at least what that would look like for the for the finite radius, for the finite value of capital R, would be something like this. So here I have my real number line. Here in pink, I've got the interval of convergence. And my number a is right in the middle of that interval. I can go as far as R to the left and still get convergence. I can go as far as R to the right and still get convergence. We saw this for the geometric series. Geometric series has an interval of convergence centered at 0. And you can go as far as 1 to the right. You can go as far as 1 to the left and still get convergence. Now, this interval may or may not include its endpoints, again, depending on whether or not the power series converges for that endpoint. So here are some different examples of power series. The first one here is the geometric series, just the summation of x to the power n. N starts at 0 and goes to infinity. The radius of convergence for this power series is r equals 1, just like we saw last week. We just have new vocabulary to describe this phenomenon now. But we also showed that the endpoints of this interval, -1 and +1, neither of those values of x will have the geometric series converge. So my interval of convergence is an open interval. It does not include its endpoints. Here is another example of a power series. This one is just from a couple of clips ago. And its radius of convergence is 0. This power series only converges for x equals 0. And so its interval of convergence is just a single point. Here is another example of a power series. This power series is centered at x equals 3. And this almost looks like a geometric series, except I've got x minus 3 to the power n. It kind of looks like a geometric series, then divided by n, starting at n equals 1. So I don't divide by 0. And similar to the geometric series, this function has a radius of convergence equal to 1. The interval of convergence will be centered at 3. So it can go as far as 1 to the left, 2, I can go as far as 1 to the right and get me 4. And more than that, does this power series converge when x equals 2? I'd get -1 to the power n on n. Oh, that is the alternating harmonic series, which I know converges. So yes, 2 is in the interval of convergence. But if I try x equals 4, I'll get +1 on n. And that series diverges. That was one of the first series that we learned about. So here's an example where the interval of convergence only includes one of its endpoints. And then the last power series on this list is that Bessel function again. This is an example of a power series whose radius of a convergence is infinite. So it doesn't actually matter where the series is centered. This will converge for all values of x, and the interval of convergence will be the whole real number line.